We have said in our previous video that any redox reaction we should be able to split it into a reduction half reaction and an oxidation half reaction. And that may be easy when you have something like this one, where there isn't much to think about. Clearly the zinc becomes zinc 2 plus, that's our oxidation, and copper 2 plus becomes our copper. There's 2 electrons leaving here and 2 electrons arriving here. This is called our oxidation half reaction, reduction half reaction. There isn't no there are no spectator ions. There are no other atoms in there that are not either the oxidizing agent or reducing agent. So it's hard. This one is much easier to split. However, there are some cases where it may not be that straightforward. So my advice is to first, most of these redox reactions are going to happen in water, so you can split all the ionic compounds into their cations and anions. So in this case, you can safely split this into this, so that at least you can identify what is it going to be reducing and oxidizing, and therefore can build the two balanced half reactions. So notice that copper is a copper 0 becomes copper 2 plus, so that's your oxidation half reaction. And in here you only have water, right? And if you remember, for water the oxidation state for hydrogen is +1. However, here becomes hydrogen, which is 0. This was our oxidation, this is our reduction. And clearly we need to add some electrons. But before we add some electrons, we want to make sure we also balance the number of oxygens. In this case, we still had this one up here. Let me see. If I put this, I can see that I actually have to put a 2 in here. Okay. And now let's see if this makes sense. The number of hydrogens, I have 4 hydrogens in here. I have 4 hydrogens in, so 2 plus 2, 4 hydrogens. I have 2 oxygens, 2 oxygens. That is fine. I just need to balance the number of electrons. Well, if you note, as we said, the number of the charge on reactants and products have to be the same. Products here have 2 hydroxides. This is 2 negative. I need to add 2 electrons here. Therefore, these two half reactions are my oxidation and reduction half reaction. It may be easy to see when I solve it. I advise you to stop the video whenever it's necessary so that you can try it yourself. It's not straightforward. One can only achieve this this level of practice just by practicing. So I encourage you to keep practicing. Please do not just take it for granted unless you have tried it without looking at the solution. So let's practice some more. And at this point, you may want to stop the video and try it yourself, because what I'm going to do now is just to solve it. Okay? We're being asked the same. Try to identify the oxidizing and reducing agent. In other words, split this redox reaction into an oxidation half reaction and a reduction half reaction. First of all, notice that sulfite is a spectator ion because it does not change. Well, first of all, first of all, these two are ionic, so you may want to write this reaction in ionic form so that you don't get confused to irons. And if you think about it, the charge on the iron here should be 3 plus, and you have 3 sulfites. And in here you have 3 iron 2 plus and 3 sulfites. You have 3 sulfites here, 3 sulfites there. These are spectator ions. We should not care too much about it because it does not really change its oxidation state. So we can just focus on the irons. Let's see what happens to the iron. So this iron goes from 0 to +2. This means that when I write iron from 0 to +2, this is an oxidation, and the difference is 2 electrons. And for iron 3, this iron 3 goes from 3 plus, and notice that even though it's the same iron 2 plus, well, there is this definitely reduces, so you're going to need one electron here. Okay, and so this is my oxidation half reaction, this is my reduction half reaction. Okay, so let's try to answer what the possible choices we have. So iron oxidizes, this means iron, because it oxidizes, is my reducing agent. Careful with this terminology. Okay, iron increases its oxidation state, we say that it oxidizes. Iron 3 plus, it reduces because it reduces its oxidation state, and therefore because it reduces, we call this oxidizing, excuse my spelling, agent. Okay, so let's see which one. So iron is the reducing agent, yes, but iron 3 plus, 2 plus, nope. There's something about sulfite, no way. So we want iron to be reducing agent. There you go. Iron is the reducing agent, and iron 3 plus is the oxidizing agent. That would be the correct answer. Now let's try to balance this. Notice that this one needs to happen twice. Yes. So if you add this all up, what you end up having is 1 iron, 2 iron 3 plus, to give 1 iron 2 and 2, that's 3 iron 2 plus. So that's what we wrote here with the spectator ion. Okay, so let's keep practicing. This only is achieved through practice. So in this case, we are being asked, when we balance this redox reaction, what is the, in this case, the coefficient for nitrogen dioxide? In other words, this guy here. Okay, so my advice here is to try to understand how many electrons, you don't even need to balance it all, but try to understand how many electrons are involved in here. First of all, identify what gets oxidized and what doesn't. Nitrogen changes its oxidation state. How is that? Well, nitric acid becomes nitrogen dioxide, and this, you have 3 -2, that is, there's a -6 from oxygen, there's a +1 from hydrogen, nitrogen is +5. From here you have 2 -2, this is a -4 from oxygen, this has to be +4. That is, you have one, whoops, there is a reduction, there is 1 electron here. Okay, we do not care too much about balancing it with hydrogen and oxygens. That will depend on the pH. Typically that sometimes is a question. You will not see that kind of question in our exams. We will not ask you to balance a redox reaction depending on the pH. But it's important to identify how many electrons are involved in each of the half reactions. And here hydrogen goes into, sorry, hydrogen, this iodine. Okay, iodine pure, right? There's 2. I need to put 2 in here because I need 2 iodines. And if you think about it, this is a -6 from here, there's a +1 from here, this is +5. Okay, this means, but +5, which is +10, because you have 2 of these, there are 10 electrons leaving here, because you have 2 iodines losing 5 electrons each. Okay, so to balance these 2, this would be our oxidation, this would be our reduction. You need to multiply this one by 5. Okay, hopefully that makes some sense. So because you need this one to multiply by 5, that would be, and you can add later, if you will, the oxygens and waters, that doesn't matter. But what's important is to balance the number of electrons. Oops, no, I'm sorry, it should be by 10. Why did I say by 5? By 10, right? 10 electrons that this reaction needs are going to be the electrons coming out of here. Therefore, the solution is 10. As you can see, I made a mistake of just counting 5. It should be times 10. So these can be a little tricky. Careful. Okay. For the last exercise, let's practice something that is very similar to this one. We are being asked again, what is the smallest whole number coefficient? Okay. So we're being asked again, what is the coefficient on the hydrogen sulfate? So first, let's identify what is the reducing half reaction and what is the oxidizing half reaction. You see aluminum 0 becoming here aluminum plus. That has to be an oxidation. And if there's a 2 in here, it's an ionic compound, but you cannot split this one in half because you will never see oxygen 2 negative in solution. So you need 2 in here, okay? And the oxidation state here is 0. And if you count how many, what is the oxidation state? Typically is -3, right? But if you are oxidizing 2 aluminums, you need to have 6 electrons leaving, each of them -3. Okay, so yeah. So now let's see, this was the oxidation. Now let's see the reduction. That should be our hydrogen sulfate. If you remember, sulfuric acid or sulfate has a +6 and it goes to sulfur 2 negative. Okay, that is from +6 to 2 negative, you need to provide 8 electrons. Okay, so as you will know, to balance this, you need to come up with the least common denominator out of these, and I can assure you that, typically you may want just to multiply them, 6 times 8, but it's none of these. Okay, to balance this reaction, these 2 reactions, you will need to multiply these 2 factors by the least common denominator or multiple of it, but definitely it's not going to be 8 or lower than 8. So the actual solution is none of this. Hopefully that makes some sense. So let me see, it should be 48, right? 8. Yep. So I wonder, or 24. 24 is the least common denominator. So if you multiply this one by 4 and you multiply this one by 3, you will have what? You will have 4 times 2. So you have this. Plus 6, right? And you have, well, let me just do the whole thing, right? 4, 8, this will be 4, and this will be 24. 24 electrons leaving, and in here you have 24 electrons arriving. 3 sulfite. Oh, wait a second. I got confused by the number of electrons. Actually, what it's asking is the coefficient on the hydrogen sulfate. The coefficient on the hydrogen sulfate is 3. There you go. That's the actual answer. As you can see, these are maybe a little tricky. Focus on what is it that it's asking. I got sidetracked by the number of electrons. We was asking about the coefficient on hydrogen sulfate. Therefore, 3 is the actual number, because the number of electrons leaving the oxidation has to be equal to the number of electrons arriving at the reduction.